Good afternoon. Good afternoon. We are here now. Last week we have started to introduce you class diagram techniques. Class diagram techniques is from Unified Modeling Language. Okay. Unified Modeling Language is a modeling language which is quite large, include many techniques. So we are going to learn some basic techniques from there for object-oriented software developments. So the first techniques we going to learn is class diagram techniques. That is for structural modeling. For object-oriented software developments, structural modeling means to model the structure of information and tasks. Also means to model those aspects that are independent with regard to time. Okay, in class diagram techniques, last week I have introduced you a very important basic concept, object. Okay. So in class diagram techniques, we are going to model things in problems as object. Okay. By using the concept object, we model both information and tasks together. We no longer do something like what we do in ER modeling. Okay, model only information. So under class diagram techniques, with the concept object, we are going to model things, the information of things and the tasks that associate with things together. Okay, that means all the things in the problem, we will model them as objects. Okay, then we will define a class diagram to specify them, to specify their information and the tasks associated with them. Okay, so in class diagram techniques, we will use class. We will use a class to specify those objects that have identical properties. The identical property means identical information and associated tasks. And we are going to define the relationship to specify the interaction between objects, that means between things, because in class diagram techniques, we model things as objects. So again, you can see that class diagram techniques is a diagrammatic techniques. And we build everything from two basic concepts, that is class and relationship type. So from this slide onward, I'm going to discuss each of these concepts in quite detail. Okay, first, last week I have already shown you how to define a class, right? This is the way to define class. We can define quite a lot of detail, okay, by giving data type for attribute, default value, etc. Okay, for task, operation is to define task. For each task, we can define a lot of information also, things like argument types, argument lists, and result type is something like what the format for each operation is similar to what you do when you write a program, function, protocol. Okay, how you define a function. Okay, so this is a more detailed format, and if you just want to define a simple class, this is an example. Okay, we only give name without specifying much things. Okay, so from this slide onward, we are going to proceed to discuss the relationship type. In class diagram techniques, relationship type can be classified into three types. First, associations. Association is to represent general interaction between different things. Okay, for those interaction between different things, we will define association to specify them. Aggregation. Okay, aggregation is a special types of association. It's part an assembly kind of association. It's a more tightly coupled kind of association. So we will discuss that also in subsequent slide. Then the last type of relationship is generalization. Generalization is totally different from association and aggregation. Generalization is a way for us to specify classification of things. Okay, things like in the companies, you may want to classify employee into various types. Okay, managerial staff, executive staff, and operational staff. You may want to classify them. Okay, so classification, generalization is a way for you to define classification. Okay, we will discuss all these relationship type in quite detail in the subsequent slide. Okay, first we are going to discuss associations. Okay, in terms of the number of classes it associate. In terms of the number of classes is specified. Okay, in association can be classified into three types: binary, ternary, and higher order. Okay. Binary association are those associations relate only two classes. Always relate two classes only. Okay. Can be to itself. And ternary are those relationship type are those association. In other words, associate three classes. Okay. From the word you can see from here, ternary means three. Higher order are those associations that associate more than three classes. Okay. Any association associate more than three classes, we categorize them into the last type, higher order. Anything above three, we classify them, we categorize them into the last type. Okay, so these are the three types of association. Okay, so how to most of the modeling techniques are diagrammatics. So they have notation for you to specify concept in a diagram. So what is the notation for binary association? Very simple. Okay. Binary association. This is the way to define a binary association. Okay. To define binary association between company and person class. For binary association, we just represent it as a line connecting the associated class. So this is a notation. This line is a notation to specify a binary association associate two classes, company and person. And the name of the association is written in the center along the line. Okay, so this is the way to specify binary association. For ternary association, we use a diamond sign. For ternary and higher order association, we no longer can use just one line to specify it. So we use a diamond to specify it. Like this case, this is a sheaf association between these three classes. Okay, between object of these three classes: supplier, project, and part. So we define a diamond to represent it and connect the diamond to all the associated class. This associated class will connect the diamond to it, and this associated class, and this also associated class. So we write the name. We write the name of the association next to the diamond. This is the way to represent, to specify ternary associations. Higher order association also specified in the same way. Also use a diamond. Okay, if you have a association associate to four classes, then again we will draw a diamond and connect the diamond to all the four classes and write the name of the association next to a diamond. That's the way to represent association associate four classes. That means it's a higher order association. Okay, so you're doing the same way for association associate. 5 classes, 6 classes, can be 10 classes. Okay, these are some examples I have already explained to you. Okay, this is an association to specify that this is a class to specify company, each and every company. So ABC company is, since ABC company is a company, so it's an instance of this class. Once you define a class to specify all the companies, then any company will be an instance of this class. Any person who are working will be an instance of this class. So here means that company, many people work for company, work for a company. Okay. People work for company, okay. And a company have many people work for them. Okay. So we define this workforce association to specify such interactions. Below this association is to define the shift interaction between supplier, project, and part. Okay. To specify all the part shipped to project by supplier. Parts are shipped to project by supplier. Okay, different part may ship to different project, maybe by different supplier, or it can be from the same supplier. Okay, so all are specified by this shift association, ternary association. Okay, so we have already seen the basic notation for specified association. So now we come to multiplicity. In the association, beside the basic notation I have just shown you, okay, we have to define multiplicity to it. Multiplicity is something similar to cardinalities, okay, to cardinalities in ER modeling. Okay. So this is a general format to specify multiplicity. Okay. J dot dot K. Okay. Both J and J must be an integer, non-negative integer, can be 0. And K is also can be a non-negative integer or asterisk, represent any value. K can be non-negative integer or asterisk. Okay? And K must be always greater or equal to J. So in other words, this is to specify integer interval from J to K. So here we have some example. 0, here we have some example. 6 dot dot 8. Okay? 6 we do dot 8. This is the multiplicity defined from the notation I have just explained to you. This notation is to specify 3 integers, 6, 7, 8. Integer interval from 6 to 8. So that have 3 integer, right? Integer interval from 6 to 8 have 3 integers, 6, 7, 8, right? So, and K. So since both J and K can be non-negative integer or K can be asterisk also, so we can define J dot dot J. Okay, if your upper limit and lower limit exactly the same, then that means we specify a unique integer only. Example 1 dot dot 1. Okay, if we have 1 dot dot 1, it can be further simplified as 1. That means you can specify 1 as multiplicity as well. That means only one value is applicable. There's another simplified notation we can use. Okay, you may have a situation J dot dot asterisk. You will follow this format. Okay. So if you have that, then you don't need to specify such a complete format. You can simply just use asterisk to represent this one. That means many, can be 0, can be 1, can be 2, can be 3, can be 100, any number. Okay? So 0 dot dot asterisk can be simplified as asterisk. Okay, this one means 0 dot dot asterisk that means can be any value. Here 0 dot dot 1 have how many integer here? 2 integer, 0 and 1. Okay, lower limit and upper limit. So we use this notation to specify integer interval for multiplicity, and we specify a multiplicity at each associated class n in the association. Okay, so I'm going to show you now. Okay, in an association, beside the basic notation as such, we should also define multiplicity at each associated class n. That means we should define multiplicity here, and we should define multiplicity here, and we should also define multiplicity here. Every associated class. Okay? So if you have n classes, then you have to define quite a number of multiplicity in this association. Okay. Now, I want to introduce you the definition of multiplicity when we define for a class as such. So if you put j dot k, that means j is an integer and k is also integer, k greater or equal to j. If you put such an integer interval at this associated class n, what's the meaning? What's the meaning? Okay, the definition is written down here. Okay, again, when you see any class diagram, when you see any multiplicity, okay, in tutorial, in any question, I advise you to follow this definition precisely. Okay, now I'm going to explain to you. If we have a multiplicity j dot k here, means that, okay, the meaning is that for every combination of object, for every combination of C1 to Cn minus 1 object, okay, here you define that this n is for the associated class Cn. Okay, if you define associated class for this one, then the meaning of this is for each combination of object, one from the remaining associated class, one from each remaining associated class. Okay, associate with at least j Cn instances, at most k Cn instances. So every time when you refer to multiplicity at associated class n, you always have to reference to each combination of object, one from each remaining associated class. One from each remaining associated class. Okay? Associate with at least j and at most k Cn instances. So that is the meaning of multiplicity. Okay? So I advise you to follow this definition precisely. Okay, we see some example later. Row. In addition to multiplicity, we can define something like ER modeling. We can give a row to a associated class, okay, to tell the function of the object the associated class play in the association as such. Okay, so company. Here we have an association, workforce association. The company class play the role of employer, and the person class play the role of employee. Okay, so we can give a role to each n as such. We can also define attribute for association. Okay, so the example is also here. This is a workforce association. You notice that I never write down any words along the line represent the association, because in this case I want to define attribute to this association. That's why I do not write down any word along this line. I do not give name to association along this line. Okay? So if you want to define attribute for association, then you will have to draw a rectangle, okay, and put the name of the association, okay, in the first region of the rectangle, and write down the attribute of the association below that. Write down all the attributes of the association below in the second region of the rectangle. This is the way to define attribute for association. So after you draw the rectangle, attach the rectangle by dash line to the association. I draw a dash line, attach this rectangle to the association. That means this rectangle is to define attribute for this association. That means for this work for associations, I define two attributes, salary and job title. Okay. A person work for a company under a certain title, and he receives certain amount of salary. Okay? So I define this class to specify all these details. Okay, so this is the way to define role and to give attribute to association. Okay, here we have an example. Okay, just now we have already discussed the definition of multiplicity. Okay, so this diagram will illustrate to you the definition of multiplicity for these binary associations. Here we have a binary association. So binary association have two ends. We give a multiplicity to each end. Okay, so what's the meaning of this multiplicity here? Okay, 1 means exactly 1 only. Exactly, that means the lowest limit is 1 and upper limit is 1. So we put 1 here. What is the meaning? Okay, the meaning is that as I explained to you earlier, you have to interpret exactly according to a definition. 1 here means that, okay, for each combination of object, 1 from each remaining associated class. For each combination of object, 1 from each remaining associated class. But since here, how many remaining associated class? Only 1, right? Only 1, because this is a binary. I'm at this end now. Okay, so remaining associated class, only 1 person class. So each combination of object, 1 from each remaining associated class. So for a binary case, okay, since we only have 1 class, so that means each object of this class, each combination of object, 1 from each remaining class, that means each object of this class, because we only have 1 class. Each object of this class, that means each person work for exactly 1 company. Each person associate with exactly 1 company in this case, because we have to always reference to object of other classes. So each person work for exactly 1 company. That is the meaning of this multiplicity. Okay, what is the meaning of this multiplicity? Again, reference to objects of other classes in the association. So only 1 other class here. This class, when we read the meaning of this multiplicity, because we are at this end. So that means each company associate with 0 to many people. Each company associate with 0 to many people. That means some company have many people work for them. Some company may not have any people work for them because there may be a new company just only set up, okay, have not employed anybody yet. Okay. So that is the meaning of this multiplicity here. Okay, now we have some more example. Okay, on top we have a binary association again, and in this case we also define attribute to the association because we draw a rectangle here, and we write down accessible by in the first region of the rectangle and access permission. That means we define the name of this association is accessible by. Okay. The first region, when you specify attribute to association, the first region of the rectangle always show the name of the associations. The second region will list down all the attribute. Okay, so that means in this case, this particular association, the name is accessible by, and it has 1 attribute. We define 1 attribute to these associations. So this is to model the accessibility of file by user. Okay. So the multiplicity 0 to many here means that, okay, reference to other classes, only one other class here. Each user, here means each user can access 0 to many files. And asterisk here means 0 to many. This asterisk means, again, each file is accessible by 0 to many users. So always reference to object of other classes. Okay. So below we have another association. Okay. The first one we have already discussed. So I just want to highlight to you the second one. This is also an association. Okay. Also association, associate two classes. Okay. But in this case, it's quite special. Okay. Both classes are the same. Okay. So this association here, this 9 connect person class back to person class. Okay. It's an association, associate persons to show the interaction between person. And this particular interaction, okay, the name is manage. So that means this association is to model the management association in the company. Management association in the company. Okay. So, and we also define attribute here, performance rating. Okay. So for this association, we define attribute called performance rating, because at the end of during the exception period, okay, the boss will give the staff a performance rating. Okay. So this is to specify such management associations. And we also define multiplicity here. The multiplicity at this end is 0 to 1. This end is asterisk means 0 to many. So what is the meaning of this multiplicity? The meaning is exactly the same in other cases. Exactly the same with other cases. Okay. So if we want to interpret the multiplicity here, always reference to object of the other class. Binary, we only have one other class. So we refer to object as instance of the other class. Okay? So that means each person work for 0 to 1 boss. 0 to 1 boss. That means a person may report to a boss or may not report to a boss. Okay? So this is correct. This class diagram is correct because in the organization, the chief executive officer, the head of the company, okay, does not report to anybody. Okay? The chief executive officer, the general manager, does not report to anybody. Okay? So because this association is to show the general property of each and every employee. So we have to include the property of the chief executive officer also. So that's why we put 0 to 1. But any other employee will report to a boss, right? So it's 0 to 1. So, and we have an asterisk here. What does this mean? Again, when you want to read the meaning of this multiplicity, always reference to object of the other class. Okay. So we always have to go to the other end. Okay. So that means here we have to start from this end. That means each person, okay, manage 0 to 1 worker, manage 0 to 1, manage 0 to many, 0 to many staff workers. Okay. Each person manage 0 to many workers. Okay, this is also correct because a person in a company may manage a number of people, okay, may not manage anybody if it's a junior staff. A junior staff will not manage anybody. So manage 0. Okay, for those senior manager may manage a lot of staff. So it's 0 to many. And in this case, you can see that the row is quite useful. We specify row also, boss, and here is worker. That means the person, in this association, the person at this end, play the role of boss. That means play the role of supervisor. The person at the other end play the role of worker. Okay. And you can see that the role is quite useful in this case. If you take out the role, it will be harder for you to read the exact meaning of the function. Okay. Object at each end play. But if you take out the role here, there's no problem. If you associate two different classes, whether you use row or you don't use row, the function that object of the class play in the association is quite clear, like this case. Even if we take out employee here, we also know that the company at this end play the role of employer, and the person at this end play the role of employee. So it's quite clear if you have an associate two different classes. Okay. But if you have association as such, associate to the same class, then the role is very useful. So in practice, usually we will define role only for those associate object from the same class. Okay. For those association or associate object from different classes, usually we don't define role. Okay, now we come to a ternary association. Okay. So for ternary association, since we have three classes, we have three associated classes, so we have to give a multiplicity to each class. Here we put all 0 to many. And this association is to, as I mentioned earlier, is to specify project use part from supplier. Okay. A project use part from supplier. So when the project uses a particular part from a particular supplier, so it uses certain quantity, maybe use 10 pieces, maybe use 5 pieces. Okay? So we define an attribute to this association. And such association is different from a binary association. There's no way for you to define a binary association, either one or two, to define all these properties. Okay. So for this case is to specify project use part, a project use a part from a supplier. So to specify such interaction between three objects, three things, there's no way for you to use binary association to specify it. Okay, from this slide onward, we are going to study how multiplicity affect the instance structure, okay, of an association. Multiplicity imply quite a lot of meaning to associations. So we are going to have some example to illustrate how multiplicity affect the instance structure of an association. So when you define a class to specify a collection of objects that have the same property, then a collection of things that has the same property, then each thing, okay, is an instance of the class. So, and when you define association to specify a type of interaction, okay, association is for us to specify a type of interaction. When you define association to specify a type of interaction, then each individual interaction will be an instance of the associations. Okay. So we can call each such individual interaction as a link, also as a link, L-I-N-K. Okay, now we have some example to illustrate how multiplicity affect instance structure of associations. Okay, we use the class diagram below as an example. This is the association to specify person work for company. Okay, so assuming that we have this scenario now, this is the class to specify person work for company, assuming that we have this scenario. For the class we have just defined, okay, three people, P1, P2, P3, all working for C1. Okay. So if 3 people all work for C1, then we will have 3 instances for this association. We will have 3 individual interactions for these associations. Okay. P1 interact with C1, okay, and P2 interact with C1, P3 also interact with C1 because all of them work for C1, work for company C1. So we have 3 interactions, and each interaction is an instance of this work for association. Okay, we can also call it as a link of these associations. We have a mathematical notation to represent an instance of association. Okay. For a binary association, okay, we can use a 2-element tuple to represent it. Any instance of binary association will always associate 2 objects, 1 from each class. Any instance of a ternary association will always associate 3 objects, again 1 from each class. Okay. An instance of associate 4 classes will always have 4 objects, again 1 from each class. So this is always a general properties. So for binary case, since is always associate 2 objects, 1 from each class, so we can use a 2-element tuple. So very straightforward. For ternary case, so what kind of tuple we can use it to represent an instant association for ternary case? Same principle, 3 elements tuple. If an association associate 4 classes, then instant association can be represented by a 4-element tuple, etc. Okay. So in this case, the first instant, mathematically we can specify as C1, P1, a tuple. Okay. We use the word tuple, T-U-P-L-E, means although we show it something like a sequence, but the order is not important. Okay. You can put it as P1, bracket P1, C1 also is the same, because tuple means something like sequence, but order is not significant. There's no order, in other words. So P1 work for C1 can be represented as this one, as the first tuple. Mathematically, P2 work for C1 can be represented by a second tuple. Similarly for the third one. If we have another company, if at this moment we have another company C2, that means C2 is also an instance of this class. Okay. But nobody work for C2 yet. Okay. If this is the case, then C2 will not involve in any instance of this association. We're not involved at all, because C2, nobody work for C2 yet. So C2 associate with 0%. Okay. Nobody work for C2 yet. So C2 will not involve in any instance of this association. That means C2 will not, mathematically, C2 will not involve in any such tuple. Right? Okay, now we proceed forward to see an example on ternary association. Okay, this is a ternary association. Okay, again, we have some scenario here to illustrate instance of associations. Okay. Okay, for this class diagram, assuming that project 1 uses 30 pieces of part 1 from vendor 1. Okay, so that means project 1 interact with vendor 1, interact with part 1, and it uses 30 pieces. Okay, so then this is an instant. Then this project 1, part 1, and vendor 1 will be associated together as an instant, as an individual instant, as an individual interaction of these associations. Okay. And in this case, for this particular instance, the value of attribute quantity is equal to 30, because project 1 use 30 pieces of part 1 from vendor 1. So for this particular instance, the attribute value is 30. And mathematically, as I explained to you earlier, the mathematical notation for represent this instance is a 3-element tuple. Okay, V1, part 1, and project 1, a 3-element tuple. Now, because this is an instance of ternary association, we use a 3-element tuple to represent it. So, and we have second interaction here. Project 2 also uses 30 pieces. Project 2 uses 10 pieces of part 1 from vendor 1 also. Okay, also that means project 2 is a different project, and that also use part 1 and also from the same vendor. So then the second interaction will also an instance of this association. Another individual, independent, separate instance of this association. Okay, so and mathematically we can use this tuple to represent the second instance, vendor 1, part 1, project 2. Okay, and since we use tuple, that means the order is not important. You can put project 2 first, then part 1, vendor 1, instead of put V1 first. That is exactly the same. Okay, so the third piece of fact, the third interaction, can also be represented according to the same method. I will not go through the detail again. Okay, now we come to binary associations. The following 2 slides will illustrate to you how the multiplicity influence the set of instances the association can have. We are going to illustrate it on the binary association first, then next slide we illustrate it on the ternary association. Okay. So we assume that for this class diagram, we assume that at this moment there are 3 companies, C1, C2, and C3, and we have 4 people, P1, P2, P3, P4. Assuming that for this particular class diagram, we have 3 companies. Okay, that means C1 is the instance of this class. C2 also, C3 also an instance of this class. And we have 4 people. P1 is an instance of this class. P2 also an instance of this class, etc. Okay. Then, what kind of instances this association can have? Okay. If this is a case, then this is a possible set of instances for this workforce associations. Given that we have 3 companies, C1, C2, C3, and we have 4 people, P1, P2, P3, P4. Okay, we can conclude that this is a possible set of workforce association instances. Why? Because this set satisfies the property, all the property of these associations. In this set of workforce association instances, okay, every person works for only one company. Satisfy the multiplicity here. You can see that P1 is only in the first instance. Okay. We use mathematical notation to represent instances here. How many instances in this set, in this first set? How many instances? 4. First, because we have 4 tuples. First, this second one, third one, fourth one. So 4 tuples. That means in the first set, altogether we have 4 instances for workforce association. And you can check. Okay. P1 only in the first instance associate with C1. That means P1 associate with only one company. And likewise, P2, P3, P4, each of them associate with only one company. So each person work for exactly one company in this set. And how about this one? 0 to many. Okay, 0 to many is can be easily satisfied. You can check. Okay, for each company, in this case, each company C1 is in the first tuple, and C1 does not appear in the second, third, and fourth tuple. That means C1, only one person work for C1. Okay, 1 is within 0 to many, so that is okay, satisfied. The company C2 also appear in one tuple only. That means associate with one person only. So 1 is within 0 to many, that's okay. C3 is in 2 instances, in 2 tuple. That means C3 associate with 2 persons. 2 is still within 0 to many, so that is okay. So this is a possible set of work for association instances. I did not say that work for association instances will definitely have this set. I did not say that this is definitely the set of work for association instances. It's possible, it's only possible because this set satisfies all the property of work for association defined in the class diagram. Similarly, the second set also satisfies all the property defined in the class diagram. So second, you can check. I will not go through the detail again, you can check it yourself. So second set is also a possible set of work for association instances. Okay, the third set is here. Third set is not possible. In the third set, you can see that P1 appear in the first instance, P1 is in the first tuple, and P1 is also in the second tuple. That means P1 associate with 2 companies. Here, one with C1 and another one with C2. P1 associate with 2 companies. Okay. But the diagram here says that every person can only associate with 1 company. Okay? So this is an impossible set of, it is not possible for work for association to have this set of instances, in other words, because this set of instances does not satisfy some property defined for work for associations. Okay, likewise, the last set is also not a possible set for work for association instances. Okay, you can easily check that. Okay, we have 4 persons. We have 4 people here, P1, P2, P3, P4. And the diagram says that each person must work for exactly 1 company. But the last element, the last person, P4, does not appear in the last set at all. P4 is not in the last set at all. That means P4, what does this mean? That means P4 does not work for any company. It means P4 does not work for any company. Okay, that means P4 associate with 0 company. So again, violate the multiplicity here. P4 work for in the last set. P4 work for 0 company because P4 is not in any of these instances. So it violates the multiplicity here. So this is also an impossible set of instances. Okay, now we come to a ternary associations. This is just a refresh of the definition. So we will go through the definition together here. Okay, so now we have a ternary association, for 3 classes, and we assume that for this association, we assume that at this moment, A have only 1 object, and B have 2 objects, B1 and B2, and C has 2 objects, C1 and C2. We assume this scenario. Okay, so again, here I list down 2 possible sets of R instances. The name of this association is R. And I also list out 2 impossible sets of R instances. Okay, why it is possible for R to have this set of instances? You can easily check that this set of instances satisfy all the multiplicity here. Okay. This multiplicity is 1. Okay. 1 means, what's the meaning of 1 here? Always reference to each combination of object, 1 from each remaining associated class. So it means when you want to read the meaning of 1 here, it means that each combination of A, B object, okay, each combination of A, B object, 1 from A, 1 from B, associate with exactly 1 C. So now we have this scenario. A has 1 object A1 and B has 2 objects B1 and B2. Okay, so how many combinations of A, B object? A1, B1 and A1, B2, right? So we only have 2 combinations of A, B object, A1, B1 and A1, B2. All right. So, and from this here you can see that A1, B1, C1 is in the first tuple and A1, B1, C2 is in the second tuple. Okay. So A1, B1 is only in this combination, A1, B1, the first combination A, B object is in the first tuple. That means it's associated in the first instance. And A1, B1, this combination does not appear in other tuples. Okay? So that means A1, B1, this combination appear only in exactly 1 tuple. That means it associates with exactly 1 C object, satisfy the multiplicity here. And A1, B2, second combination, also appear exactly 1 time. So that means associate with exactly 1 C object also is in the second tuple. Okay? So every combination over here, because this is a scenario we have. A1 have 1 object, A2 have 2 objects, B2, B1, B2. So both combinations associate exactly 1 C object. So that satisfies the multiplicity here. And you can easily check that. Okay, you can also easily check that. It satisfies the multiplicity here as well for the first set. So it satisfies all the multiplicity. That's why this is a possible set of R instances. Why satisfy the multiplicity here? Okay, so here is 0 to many. That means each combination of BC object. So when you read the meaning of multiplicity, always reference to each combination of object, 1 from each remaining class. So we are at this end, remaining classes B and C. So that means each combination of BC object associate with 0 to many A object. So we have 2 B object here, B1, B2. We have 2 C objects, C1, C2. So how many combinations of BC object? 2 times 2, 4. They are altogether 4 combinations of BC object. What are the combinations? B1, C1, B1, C2. Okay, B1, C1 is in the first tuple, and B1, C2. Okay, B1, C1 is only in the first tuple. That means associate with exactly 1 A object. It's only in the first tuple, associate exactly 1 A object. So that means it's 1. 1 is between 0 to many. That is okay. Okay, and BC, second combination, B1, C2. How about B1, C2? B1, C2 is not here, and B1, C2 is also not here. That means B1, C2 does not appear in any tuple. That means it does not associate any A object, B1, C2, associate with 0. In other words, associate with 0. So 0 is okay. It's within 0 to many. Okay. Likewise, B2, C1. Okay. B2, C1 is not here. It's not in here. Associate with 0. And B2, C2 is in the second tuple. Only in 1 tuple. Associate with only 1 A object. So that is okay. 1 is within 0 to many. Okay. That means some BC combination associate with 0 A object. Some BC combination associate with 1 A object. So that is all within 0 to many. So it satisfies the multiplicity here. Again, you can easily check that it also satisfies the first set, also satisfies the multiplicity here. Okay, I will not go through the detail. Second set also satisfies all the multiplicity. So that's why second set is also a possible set of R instances. Okay. The third one, okay, the third one listed here is not a possible set of R instances. Why? Because the scenario given here, A have 1 object A1, B have 2 objects B1, B2. So they are all together how many AB combination? A1, B1, A1, B2. There are 2 combinations of AB objects. Okay, so the first combination is in the first instance, A1, B1, C1. Here, the first combination appears in the second instance again. What does this mean? That means the first combination associated with two B objects. Two C objects, sorry. The first combination, A1, B1, associated with two C objects because it is in the first instance and also in the second instance. That means the first combination associated with two C objects that violate the multiplicity here. Violate the multiplicity here. As far as there's one violation, it cannot be a possible set of R instances. Okay. Likewise, the last set is also not a possible set of R instances. Okay, you can check that for the last set, the first combination is okay. A1, B1 is okay, associated with one C object because it's in one instant only. But A1, B2, the second combination, okay, is in the second instant and also in the third instant, associated with two instances of C. So it's not that violate the multiplicity here, because here say that each combination AB must associate exactly one C object. Okay, so from here you can see that multiplicity implies a lot of meaning. Multiplicity influences what kind of set of instances an association can have. Okay, I have illustrated to you quite detailed through a binary, through a ternary case. Okay. For associate 4 classes or 5 classes, the meaning is exactly the same. Okay, so I hope you go back and you think over. If you've got any questions, okay, please do write me email or make an appointment to see me.